Hello everyone and welcome again to our channel. In this video we are going to apply a static search algorithm over this tree structure. We are already provided with the values of path as well as the value of node in this diagram, and we are going to apply the algorithm, a static algorithm, in order to find the path to reach the goal from start node. So now we will start with a static search algorithm. This one is also called informed search algorithm because we are provided with the cost of path as well as the cost of node. So the heuristic function that we use here, it is f of n is equal to h of n. H(n)f is the heuristic value that represent the value or the cost of a node from the goal node. It means this approximately this amount of cost we need from a node to reach our goal node, whereas this g of n is the value of the path that we have traversed so far to reach a particular node. For example, to reach node C, we used already this values. This cost 9 for this path, 7.3 for this path. So 9 and 7.3, it becomes our 16.3. This is value of the path, that is GH. Plus we will add the value of H of n, that is the node value, node cost, that is 5. So this is how we can get the value of Fn, or the value of heuristic function Fn. So now we will apply our algorithm. I think it's better to firstly count out the values of different nodes here, but it will make it easier for us to choose one node over another by performing the traversal of this tree structure. In case of A, if we say A, so the f of n value, or heuristic value of A in case of a static search algorithm, is 11, because 9 and 2 here, 11. So let I write with this ballpoint, so with red one, so we can understand this. 11. For B it is 11 and 8, 19. For C it is, as I mentioned, 16.3 up to this point, plus 5 is the value of C, so it becomes 21.3. For D it is 28.5. For E it is 35. For F it is 21. You can count it actually, I already counted 21. For G the value is 25. For H it is 29. Since it is 6, the total one is 29.3. For I we have 25.3. For J the value is 27, and for K we have value 32, where this is 6. For L it is 26.3, and for M it is 35.3. For N the value is 50, and for O is also 50. So if you add up those values plus the value of node, we need to remember that in order to find out the heuristic value of a node using a static search algorithm, we will just take the values of path as the value of Gn plus the node value itself. The nodes that are in way from start node to a specific node, we will not take the value of that particular node. For example, here in this case we will not take the value of A, these two, but we will take the value of path. Like this it will move 9, 7.3 and C. So this is how we will calculate values of all the nodes in case of a static search. Now we are going to apply our algorithm on a static search. As we used to do, firstly we have just to list, close list, and the open list we call them also, of course this can be represented with a variable k that hold the values of current nodes. So now in the beginning we have start list that is having a single node, that is s, whereas k is empty. So when k value of, when we remove s, the first node from start, we give it to variable k. Here it is compared, it is goal. If not goal, we will follow a particular procedure according to which we will firstly expand the s to its successors, its child nodes, which are a and b. But again, how we are going to arrange them, it depends upon their heuristic values. The one that has lesser will come first, and the one that has more value will come later, so that we can find out the path that gives us, or that needs the least cost to reach the goal node. So s, we give s to this variable. S is limited from start, and it is represented by its two other child nodes that are a and b. And what will be their sequence, since the value of a is lesser? So it will be like this: start a and b here. Now we move to again back. That means we again give the value of a to this variable k, and a will be replaced by its child nodes. Now the value of a will be replaced by c, d, and e. But we see here that the value of b is less than them, so it means the new sequence here in start will be firstly we will have b, then we will have c, then we have d, and then we have e. So this is our sequence. Now what we will do, we will remove b from here, and we will give this a value to variable k. So value of k variable will be, new value will be s, a, and b, and b will be replaced by child nodes. What we have here, we have f and g. F is 21 and g is 25. So here if we see value of c is 21.3, this is more of the, so these two come in the beginning. So now this sequence will be we have f in the first place. Sorry, this is more. So basically with f, then we have c, then we have g, then we have d, and then we have e. Now k will get the new variable, that is f from here, f, and in start we might have some new nodes if f has some successor. F has successor, yeah, it has j and k, that are 37 and 32. Now the new arrangement after removing f from the list will be c will come first because it's still the smallest one, then we have g, then we have j, then we have j, then we have d, then k. After f, c, g, d, and e, we have new sequences c, g, j, d, and k. K is the also the child node, and after k we will have the value of e. because you see E is 35 here and K is 32, so the lowest values come first. Now after another iteration, C will go to variable K, A, B, F and C, and new start list will be to C has some successor here, it has H and I. Values are written here 29.3 and 25.3. So the new sequence after removing C will be G, then we have I, the new child node, so less value that is Y, then we have J, then we have D, then other child will come here, H 29.3 that has value, then K, and then we have E. So now again we will see, do we have this is our goal? No, not yet. Again we'll follow same procedure. Now this time we are going to take the first element again from our start list and we'll just give value to our variable K. So here we have this G. Now the new start list we have here will be IJ. G has successor here? No, so it will be same. I, J, D, H, K and E, because that J don't have any successor. After J we have I. Do I have successor? Yes, I have successors. So it means when we remove I from here, B, F, C, G, I, so start list will get some new nodes that are the successor or the child nodes of I, which are L and M, but we need to see their values to arrange them in our start list. So after removing I, we will have first the L, the lowest one, then we will have J, then D will be same place, H, K, M will come before E because M is 35.3, whereas value of E is actually E is less than it. E is 35, and so after removing I, we have two variables, the children node L and M, but the M is 35.3, which is more than the value of E. E is 35, so E should be here and M should move to end. Okay, so now we are going to remove the next one, that is L. L has any child node? No, so L we will remove from it and we'll add it to our list K, our variable K, F, C, G, I and L. Now the start list will be get J. J has successor any? No, so we can also remove just J from here and also add this J to our K here. Okay, so now then we have D after them. So D also has successor or not? D also don't have successor, so D also we can remove. So just to cut short it, I can write them like this: A, B, F, C, G, I, L, J, D. Then we have H. Do H have any successor? Where is H? No, H also don't have, so H we can also write with it H. Then we have K. Do K have successor? Yes, it has N and O, which are 50-50. So it means on removing K from here, so this will be replaced by its successor that N and O, which are 50-50, that are more than value of E and M. So new list will be like E, M, and we have N and O. Again iteration will come. Now we will remove E from here and we'll give it to this one. Do E has any successor? No. Then we will, next iteration we will again iterate over loop and we will remove M from here. So M will come here. So now what will be the cost of the path? This is the path that we need to follow to reach from start to node M. It will be cost of all nodes S is 0 plus A. A was, what was A? 9 plus 2, 11. It was 11. 9 plus 2, 11. 9 plus 2, 11. So A is over 11. First of all, we will write A 11 plus B, that is 19, plus F, that is 21 plus 21.3. Then we have followed by 25 plus 25.3 plus 26.3. Then we have plus 27, then plus 28.5. Then we have value of K, that is here, what we have here, K value, K is 32. Do we have 32 already? No, not yet. 32 is not yet, so we need to add 38. Okay, let's start again from the beginning. C0, A is 11, B is 19, then we have F we have here 21, G we have here 20. After C, G we have here 20. Hello everyone, once again to our channel. Now we are going to work on beam search. In case of beam search, we are provided again with a heuristic function, that is this h of n, and based on this value we are going to arrange our nodes in the list start list. Here what we need to remember, that we are provided with a beam value. Here in our case we are provided with the value of 2, so value of beam here is 2. So it means at each level we can expand only 2 nodes. Yeah, from start we can just keep 2 nodes and we can discard all other nodes. Now we are going to start working on it. We can see how it actually works. So let's start with it. So again, here usually we have a variable K here that will store the values of the nodes currently explored, whereas start will keep those nodes that will get explored in future. So in the beginning we have value S, just S value. When S will be removed from here and will give to variable K, and it will be compared is our goal or not. If not, then what we will do, we will generate a successor A and B, and we will see their values here, H and M values. The smaller will come first. Here in start we can have equal to or less than the value of beam, that is 2. We cannot have variables or nodes more than 2, but for beginning we just have 2 because the S node has just 2 successors, A and B, so we can keep them, both of them here, A and B. Now during second iteration, A will be eliminated and will give to variable A. Now we see, do A has successor? If it has, we will see their values. Yeah, A has successor. We have successor here, A, that are C, D and E. Their values we can see from here, and C is 5, and D is 11, E is 18, and B is, as it was here, it is 8. So it means C, B, D, E. So our new start list will be C, B, D and E. Now when we get the value of C, as A and C, again as I mentioned before, just we keep 2 of them. It means this D and E will be discarded from the start, and we will just keep the 2 of the nodes in star list here, because the length of beam is maximum 2. So now we will take C from here to explore. Now we will see the child nodes of C. Do we have or not. See, also have child node H and I. Here we see their value. HI is 7, I is 4. So new sequence will be here. I, because I is the minimum, 4. Then we have H, and then we will have B, because B was 8. Again we are going to discard 8 and we will just stick with 2 values. Now during next factorization, the value of K will be S, A, C, and this one that is I. If we remove I, do I has any children node? Yes, L and M. What are their values? L is 3 and M is 14, which is more. So first of all we will have, in start node we will have L, then we will have H, and then M. But the value of M here is greater, so we are going to discard M and we will just keep over these 2 nodes L and H. So new sequence will be S, A, C, I, L and M. Now we will take out L. And see, L has child node? No, I don't have any child node, so start will be left with just node H. H will be here. Now if we take away the node H from start, it will be replaced by its children node that are, we know we don't have any children node, so it means this is our sequence. But here at the end of the search we didn't found goal. So that is the solution. So if we can add the cost, if we want we can find out the cost, but the solution is that we didn't found the goal by the end of the search. Thank you for watching this video.